We are Team Intune. What are we doing? We are building a fully autonomous, self-improving LLM framework, which can teach itself, evaluate itself, and fine-tune itself with the customer-grade hardware. So we have done this using three repositories. One is the front end in React, which does a simple chat-like interface. One is the backend, which performs the generating the answers, doing the evaluation before and after fine-tuning, and does the fine-tuning process using LoRa. And we have another backend which handles the OpenAI system using GPT OSS 120 billion parameters, which acts like a supervisor generating high quality training data.
How are we doing this? We solve this problem by building a distributed, automated self improving pipeline using a teacher student architecture, offline evaluation, and LoRa fine tuning on cheap hardware. First, teacher student system. We use ChatGPT OSS 120 billion parameters as a teacher and Gamma 31B as student. Teacher generates ideal answer context, and this removes the manual need of data creation. Second, our intelligent status driven workflow. We use Supabase for recording the state, status flags, matrix storage, and task assignment. This allows a non stop self improving system. Third, offline evaluation framework. So, no APIs are needed. We compute 8 metrics locally, so no need of any OpenAI, API, external services, and cloud computing. Fourth, effective LoRa fine tuning on 8 GB VRAM. We use we use LoRa rank 16, AdamW 8-bit optimizer, and NF4 4-bit quantization. This allows fine tuning on low-end GPUs as well in 4 to 5 hours with a high performance rate. The overall architecture of our project, we have three main repositories: front end, back end 1, and back end 2. Olama, which runs in backend 1, OpenAI OSS, which runs in backend 2, and database is Supabase. So the user comes in front end, gives us the prompt. This prompt is then sent to the backend 1. Backend 1 receives the prompt and calls OpenAI model. OpenAI model takes the prompt and generates the output. Once the outputs are generated, then it gets stored into the Supabase with actual output and status created. So this actual output gets stored in Supabase. Once these things are stored in Supabase, backend one constantly runs a script which keeps on pulling the rows with status created. If the rows are found, it takes the input from the rows, sends it to OpenAI OSS and gets the expected output. And then the expected output with the status are then stored into Supabase. And if the rows are not found, it keeps on pulling again and again. So this script constantly keeps on pulling, and this script also constantly keeps on pulling the rows. Another script which runs in backend one is it keeps on pulling the rows with status ready. If the rows with status ready and all columns are present, it performs all these matrices, and all these metrics along with overall score are then updated in Supabase with status done. This status with this status done shows that these rows are ready for fine tuning. So in fine tuning in backend one we run another script which checks if the status is done and if the rows are greater than 5000. If the rows are not greater than 5000, it waits till we get rows greater than 5000. Once we get rows greater than 5000, it performs fine tuning and it regenerates the actual output on fine tuned model, and the actual output is then again re-evaluated and then updates the final status to done. This shows that this rows won't be again used for fine tuning, and all these things are then again stored into Supabase. So this is the overall architecture of the self-learning LLM framework. This is the front end page of Intune where you can select the model. Currently, it only works for Gamma 1 billion, which is the student LLM that we aim to improve simply by using it. Users provide an input which then calls the backend. Backend calls the model and then returns the output. Both the input and output are then saved in the Supabase with status created. We need to keep this endpoint running, which gives us the output from the model. In backend 2, we need to keep this script running constantly. This script constantly fetches the rows from Supabase with status created. For each input, it calls the teacher model, which is the OpenAI OSS 120 billion parameters, and updates the row with expected output and content, and changes the status to ready for further evaluation. As you can see, the Supabase is updated. In backend 1 again, we need to keep another script running in another terminal which continuously fetches the rows with status ready. It performs the matrix evaluation on these rows and update the score in Supabase and changes the status to red done. In the same backend, in another terminal, we keep another script running. It continuously checks whether the number of rows with status done are greater than 5000. For this video, we have kept the limit to 2, and once the condition is satisfied, it uses the data from Supabase and performs fine tuning. After fine tuning, it loads the fine tuned model and runs it on the same input. Based on the output, it computes the matrix again and updates the Supabase and sets the status to final. These rows won't be used again for further fine tuning in the loop.
So by simply keeping all these three scripts running in the terminal and using the student model output, the entire self-learning framework runs automatically. It continuously performs evaluation and fine tuning, and the student model keeps getting better over time. Thank you.